Welcome to Ask and Learn.
In this problem, we have a collision between a car and a barrier, and the force of this collision varies by F equals to 90 times 10 to the 3 times x to the 1/2 pounds. We're also given the weight of the car, which is 4,000 pounds, but we can convert that. If we divide by 32.2 feet per second, we can get the mass is 124.2 kilograms. And we're also given the speed of the car, which we'll call v1, right before the collision, and that's given as 75 feet per second. So in this problem, we want to find the maximum distance the car reaches before it makes a complete stop, and we'll call that x max. So because we're given a force and we're looking for a distance, and we're also given the velocity of the car, we can use the work energy principle, which is just the initial kinetic energy plus the work being done is equal to the final kinetic energy. Of course, we can expand T1 and T2, so we have 1/2 mv1 squared plus the work being done is equal to 1/2 mv2 squared. Well, we know that once it reaches a complete stop, the car isn't moving no more, so its final velocity is 0. So the right side is 0, again because v2 is 0. So this makes our equation just a little bit more doable. So now we're left with 1/2 mv1 squared plus the work being done is equal to 0. Now because the force F is not constant, the equation for work becomes a little bit more tricky. So work, the second part of the equation, is equal to the integral f dot dx, and the bounds are from 0 to x max, which is what we're looking for, the final distance when the car stops. Now we can just plug in what we know f to be, which is given. So f is 90 times 10 to the 3rd x to the 1/2 dx. So we're really looking for the integral of this, x to the 1/2. So now we have 90 times 10 to the 3rd. So the integral of x to the 1/2 is 2/3 x to the 3/2, and the bounds again, 0 to x max. So now we're left with, for work, we have 90, 10 to the 3, 2/3, so now x becomes x max to the power of 3/2. So now we can plug this back in to our equation, and now we can plug in some of the numbers we know. So we have the initial kinetic energy, 1/2 m, which is 124.2, times the initial velocity, which is 75 squared, and then plus what we just found, 90 10 to the 3rd times 2/3 x max 3/2, and of course all of that equals to 0. So now we can clean this up a bit, because we're really looking for is x max. So now these numbers become 3.5 times 10 to the fifth plus 6.0 times 10 to the fourth x max to the power of 3 over 2. Of course, that equals to 0. So I can move 3.5 times 10 to the fifth to the left side, giving it a negative sign, and then divide by this to get x max by itself. So we have x max is equal to minus 3.5 times 10 to the fifth divided by 6 times 10 to the fourth. And x max has the power of 3 over 2. So to get rid of that, you multiply both sides by the power of 2/3, so the opposite, to get rid of it. So then now x max is equal to 3.24 feet.